The first problem we're going to notice always when it comes to solving a trig equation like this is we've got it in terms of instead of theta, 2 theta. We always need it to be in terms of just theta or just x or just whatever it is. But this is 2 theta, so the first thing we're going to need to do is make this substitution. So we'll call this x equals 2 theta, which allows me to write the equation like this. And this is now in a form that I can deal with. However, I have changed the equation, and therefore I must change the interval. Now what I'm saying is now that x is twice what theta is. So I'll rewrite this. And we've got our new interval. Now we can go on to solve this. We've got this tan squared function, so we need to undo this squared function, and the inverse of squared is the square root. So I'll take the root of both sides. Now this is extremely important to commit this to memory. Whenever you undo a square root, you don't merely end up whenever you undo a square, you don't merely end up with a square root, you end up with a plus or minus square. If you're going to progress in maths, that is something you've got to memorise and basically never forget. To undo a square, yes, you take the square root, but it's the plus and minus the square root, and the interval doesn't change. So effectively now we've got two equations. On the one hand, tan x equals root 3, and on the other hand, tan x equals minus root 3, both of which we're going to need to solve just using your calculator, and what you'll find is x equals 60 degrees, and for this equation x equals minus 60 degrees. But remember, we've only found the principal angle here that the calculator gives you. Now with tan, there's no we might sort of call partner angle. There's no symmetry that we need to worry about, but we need to do need to worry about the periodic function, and that we're going to add and subtract multiples of 180 to these solutions. So if I write down my principal angle here, I'm going to add and subtract multiples of 180 to find the solutions that lie within this interval. Now if I subtract 180 from this, I'll end up with minus 120. So I don't need to go any further back because this falls outside of the range. But I can add 180 and I'll add another 180, and indeed another 180, and I'm still not falling out of this range of up to 720 degrees, and another 180, and at this point I can stop because I know that this is out of the interval, so there's no point in proceeding any further. Now the minus 60 is already out of range in terms of it being less than 0, so I don't need to go back, but I will add multiples of 180 to it. And again at this point I can stop because I've fallen out of the range. Now again, as with the method here, what we found is x. We've solved this equation in terms of x, but it's actually theta that we need to solve. So as long as we remember this substitution here, we know theta equals x over 2 actually. So in other words, I'll just halve these solutions. Now I'm just going to look firstly at which of these fall within our interval that we require, so between 0 and 720, which is this solution, this solution, this solution, this solution. So these solutions, so it's only these that I'm going to bother looking at. So for theta, I'll simply halve them. And so there we got in total 8 solutions here. 30 degrees, 60 degrees, 120 degrees, 150 degrees, 210 degrees, 240 degrees, 300 degrees and 330 degrees. If you got this wrong, it's common to forget to take, when you undo a square, it's common to forget that you need both the plus and the minus of the root.